we're going to be introducing ourselves to a series of the laws of the logarithms. The laws of the logarithms, alright? And if you go back to your indices, I always relate logarithms to indices because they're basically more or less very similar. If you go back to indices, you'll find yourself a series of laws, kind of like where we have a to the n times a to the power m is equals to a to the power n plus m, and you know, the subtraction and with the division and everything of the sort, and you get a series of laws like this, right? All kinds of interesting laws like these. Well, it just so happens to be that the logarithms have their own set of laws. They have their own set of laws, and I'm going to show you the first one. Well, I know log to my base of a, which gives me b, plus log to my base of a, which gives me c, is always going to be equals to the log of the base a, right, of b times c. And I know this is initially a lot to take in. This can be initially a lot to take in, but it's actually quite simple once you get the hang of it. And you're probably wondering, well, why should I take your word for it? Why should I say that log base a of b plus log a of base a of c is the log base a of the multiple? Well, I have a video where you have complete proof of this, and I always encourage you to look at proofs, so maybe it helps you understand it better. And you should check it out just in case you're not satisfied with me just telling you that so blatantly that this is what it is. Well, here's something I want you to notice. In all these three figures here, over here, over here, and over here, my log has the same base. And in this case, my base is always the same. In this case, it's always the same, and in this case, it's always a, right? It's always a, log base a, log base a, log base c. If I had you something like log base a of b plus log base x of c, you cannot say that this is log base a of bc. This is absolutely wrong, unless you're given extra details about the question, which kind of give you a completely different situation. But generally, you cannot do this, and I'll show you exactly. I'll show you examples, so maybe you'll get the hang of it. Let's say we had, let's change the colors up a little bit, and let's say we had log to the base 3 of 2, right, plus log to the base 3 of 3. No, I don't write 3. I want to change this to 4. Log to base 3 of 4. Well, just like the law said right above, I want to keep this close so you can always refer to it. I know that my answer would be log to the base 3 of 2, right, times the 4. Oh, by the way, over here, this decimal point looking thing is basically my short way of writing multiplication. What I mean with decimal is not b point c, it's b times c, okay? And most books might use that just to prevent the multiplications looking like the x or something of the sort. Let's try another one. Let's say we had log to the base 2, right, of 5 plus log to the base 2 of 10. Well, I know my answer will have to be log to the same. Notice how these questions have the same base? Well, in this case, my answer should have the same base as well. That's the only way this is possible. Log to the base 2 of 5 times the 10, which would be, right? Oh, let's solve the first one. I forgot about that one. This would be log to the base 3 of 8. 2 times 4 would be 8, and here down here would also be log to the base 2 of 50. Right? Because 5 times 10 is 50, and 2 times 4 is 8. I hope I didn't get you all jumbled up. My bad. I was distracted up a little bit. Let's try one more so we can say the point has actually hit home. Right? let's say it's actually made sense and sunk in. Let's say we had log to the base 5. Oh, 5, a big base, something more daring. Of 7 plus log to the base 5 of, let's say, in this case, let's try and make it big. Let's say 15. Okay, why not? Well, this would be log to the base 5 of 7 times the 15, right? This would be 7 times 15. Well, that's 7 times 15, 5. Carry the 3. 7 times 1, more 7 plus the 10 plus the 3 is 10. 105. This, oops, let me write this in. I forgot log. This is log to the base 5 of 105. My bad. And I see you probably making sense out of all of this. And questions may not always come so straightforward, or you may be asked something less direct. Maybe they'll say solve for x in this example. Solve for x. And they might go ahead and tell you log to the base 2 of x, right? Plus log to the base 2 of 3 is equals to log to the base 2 of 9. Well, the first thing you want to do is simplify what's on your left hand side, because it looks like it's pretty long and you want to crunch it up into something really small. And you know, well, log to the base 2 of x, right, plus log to the base 2 of 3. Let's have a look at it first. Well, we know both have the same base, so what we know to do is to just multiply the result. In this case, log to the base 2, and I always like to refer to these numbers here in the bracket as results, because, you know, exponents, like I showed in previous videos. Well, this will be log to the base x, log to the base 2 of x times 3, which would be log to the base 2 of 3x, right? Well, we were also told, so we know now that log to the base 2 of 3x is equals to log to the base 2 of 9. Well, most math books, you might find them sort of canceling the log 2's out, and then you conclude by saying 3x is equals to 9, right? And the x would be equals to 9 over 3, which would be, in this case, equals to 3 in the end. X would be equals to 3. Well, personally, I don't enjoy this log of 2 crossing out, basically because log of 2 alone makes no sense. In fact, log of 2 of 0 itself makes no sense. In one of these videos, I'll show you exactly why this funny looking thing here makes no sense. And just having log to the base 2 alone also itself makes no sense. I don't like to cancel it out. But when you stop to think about it, what you're trying to say is the power, right, over here, right, the power I raised 2 to give me, right, power which I raised 2 to give me 3x also happens to be the same power I raised 2 to give me 9. So I know that this power right here is the same as this exponent. Okay? Therefore, it's like kind of like saying if I had 2 to the power 3 is equals to 8, I'll just say 2 to the power blank is also equals to, let's say in this case, 2 times 4. I'm just expressing it in a different way. Well, I know this exponent is also 3, right? So I know 2 times 4 is 8. And in this case, 9 is equals to the 3x. Because I'm raising the 2, in this case, both of them to the same power. I'm raising 2 to the same power to give me 3x, and 2 to the same power to give me 9. Right? Therefore, 3x must be equals to 9. Therefore, 3x must be equals to 9. But if it makes the algebra easier, go ahead and cross out. I'm not going to dictate your way you should carry out mathematics. Like my teachers always say, many ways to kill a rat. Many ways to kill a rat. And you should just, find what you're comfortable with as long as it makes sense. Alright?